Uh, right? So variable one, this is the space you need. These are the variables. You need variables to store numbers. Now you know what is the algorithm. What is the algorithm? You need a sum, right? Finally, you need sum. So sum is equals to variable 1 plus variable 2 plus variable 3 plus variable 4. Got it? So this all these numbers are added and solution is added into sum. Now, if you want to print what this answer is, you would go ahead and say print sum. Don't worry about it. So print sum. So you will be printed with the sum. So I think I can bring the camera a little bit down. Yeah. Okay. So print sum. Now you got the sum. Now this is your, you can surely say, you can write it in this way or you can write it in English, saying that, okay, step one, right? Step one, declare 4 variables. Step two, assign values. Step three, add them. Step four, assign the sum, assign the sum to a new variable. Step 5, print it. So that's a 5-step algorithm, right? 5-step algorithm. So once you know these 5 steps, now what you have done here, this is the fairly simplest problem, even my kid can solve, right? Now these 5 steps, you've translated your understanding of summing 4 numbers and got a solution. What does it take now to solve algebraic equation, to solve prime number, right? To solve sum of integers 1 to 100? Can you relate it now? So solving 1 to 100, it's easy, right? But will we declare 100 variables? No. Do you? You don't, right? Variable 1 is equal to 1, variable 2 is equal to 2, variable 50 is equal to 50. No, we don't do that. So there comes the programming construct. So when I want to say programming, I wouldn't say P-R-O-G. No, right? I don't spell it. I just say one word, programming. Likewise, now what do you, in order to solve that addition of 1 to 100, sum of integers from 1 to 100, sum of integers from 1 to 1000, or if I change sum of integers from 10,000 to 1 million, the computer is for that. It should be able to solve and give me the answer. But then who instructs it? Your father or mother, comes and says, get up in the morning, go to the college. There is somebody giving you instruction so that you're doing it. And you give it to your younger sibling. So he's doing it. So here we follow this master, the master-slave architecture. Your father is a master, your mother is a master. So she or he is instructing you and you are performing that activity. Your professor is a master giving you assignment, you are performing that activity. You are the master instructing the computer. You are the master instructing the computer. So you should know what to instruct, what to code. So this is what you think. Now, I hope it gave some sense. You might know this, but I'm telling you, the difficulty is not in learning something big. It is understanding these fundamentals. You can solve any problem now. Even if I give you, sorting of a book, finding a particular word inside, a paragraph, you should be able to solve now. Because now first you must solve it on the paper. What is the problem? Do I understand the problem? Do I have every data given to me about the problem? So that is the most important thing. Nothing else. So programming is not Rocket science programming is not something, you must be really champ to become. No, programming is for everybody. When you can speak Kannada, when you can speak English language, you can write your brain processed whatever the sum that you have solved, you should be able to speak in that language, write in that language, C++, Java, C, Python, Go, right? Rust, name a language, you should be able to write it. So programming is not difficult, team. So my dear students, programming is the easiest thing to do, provided you settle down first. You cool down yourself, right? You do not you do not want to rush. You want to slow down. First understand the problem, then solve the problem on the paper, then write an algorithm, then go to your programming language. Coding is the last step. Much before that, you must solve so many things. Very fundamental, right? So having said that, let's get on to the first questionnaire. No, I'm one thing I so happy to see. Maybe I'll share the screen so that you will also see the happiness that I have. Uh, you see the responses here, right? Name five programming languages. I love this C++ part because that's where I began my learning. I first started off with C. Then I learned C++ on my own. Then rest of the languages came in. If you ask me, even today, if you give me a problem, the first language that I choose to write is C++. Not Java, not Python, not Go or anything. So though I write in Python, I write in Java today, but still, we say that, right? Okay, if you are asked in a dream, if you are asked to wake up and then asked to write which programming language, I write in C++. So I'm very blushing to see these all C++. The question here is name five programming languages that you are aware of. So this gives me so much of no, yeah, we all belong to some same place kind of thing. Good. So
And our chief executive CE sir has responded with a response to that questionnaire.
Sorry, ma'am, I couldn't follow you.
Our CE sir has
Yeah.
responded to the questionnaire.
Okay.
Just
Okay.
his skills or general knowledge. That's what he has told.
No, I'm very happy that you're also. I mean, there's also participating. That is very encouraging to all the students and to me as well. You know, this is very good, very good gesture of your college, I would say. I'm very glad to see that. Even all of you should make an attempt. These are fundamental questions. My ability here is to take out what you have, take out inside you, right? That problem solving, then algorithm, then code. That's what it comes, not anything before. Okay, guys. So we are moving on to the next part of the session. Now we have seen. Um, uh, so yeah, please continue to ask your questions. I said five, but I don't mean to stop at five. Even 50 will take time to answer them. Okay. So, and guys, you are all BSc grads, first years. You should be boiling with your, energy. Okay. So keep ready. Keep having your questions. Send them here in the chat. So now, so you have understood what happens when you are given a problem. You understand the problem first. Is everything there in the problem? If something is missing, the question is incorrect, question is incomplete, right? So then you write, solve it on the paper. Forget about computers, forget about programming. It doesn't come first. Even today, see, I work as a software architect, as you know, right? So I still get to write some code. I still get to solve problems. So that's my major job. That's why I get paid, right? You will also be paid tomorrow for the same reason, solving problems. So the very first thing that I do when a customer comes and tells that, okay, I want this feature to be in the product. Okay. And oh, okay, let's sleep up and then go. Let me sit in front of my computer or sit with the engineers and then code it. No. If I do that, I am going to be a failure. My product is going to be failure. Customer is going to be unhappy. Surely, guaranteed. I guarantee this. If you want to do this, if you want to give it a try, yes, you are heading for a failure if you do that. Right? The first thing is, what is the problem? What is the problem? Is everything conveyed inside the problem? Okay. So now I'll tell you the problem. One example for that. Now we take, okay, sum of integers from 1000 to 10,000. Simple problem, right? You make an attempt to solve it on a paper. First thing, as we have been talking, same method. I don't deviate from the method. Solve it on the paper. Okay, how do I solve it? So 1000, I add, right? 1001, 1002, 2000, 2001, 2002, goes on till 10,000. Then sum them up. That's where the calculator came. So you know the method. What is the method? See, observe here carefully. What is the method? First, you are taking a starting number. Agreed? You are taking a starting number first. What are you doing to it? Adding plus 1 to it. Isn't it? You're adding plus 1 to it. So you're adding plus 1 to it. Then the next number is coming. Then, right, you're adding plus 1 to it. 1001. So it comes your 1002. Then 1003. So on until 10,000. This is where you stop adding any more 1 to it. Isn't it? This is what we're doing. 1000, add 1 to it, I'll get 1001. And this is only to generate the sequence of numbers. But here the question is sum of integers, right? Sum of integers. Now, in addition to this increasing this number, what is that I do? Okay, I want sum. Sum is equal to the very first number, right? The very first number plus the sum itself. The sum itself, you're getting this. This is one logic. Again, in programming, that's the freedom we have. You can come up with one logic, I can come up with another logic, someone else come up with their different logic. So you are in order to get, how do I get 1000 to 10,000? By adding 1 every time. That is part of the problem understanding only. Now, how do you sum them up? Okay, how do you sum them up? Let's not go there yet. So, okay, 1000. Then I will add 1001. So this becomes 2001. Right? So that becomes 2001. Now 2001. Next is 1002. So I'll have to add 1002. So this gives me 3003. So what is that I'm doing? Now I add first two numbers. So this is unavoidable, right? I must add first two numbers. So what I do, I'll take 1000 as the first number, okay? Variable 1 as 1000. So this I'm solving it here, right? You know now. How did I solve it here? To increase the numbers, I'm adding 1 every time to the number. And every time I'm adding two numbers, sum and add next number, add next number. Right? Sum, add next number, sum, add next number. That is the logic. This is the important thing to be a programmer. Remember. You might think, it's so easy. But did you get it? Did you get the method? Did you actually understood the series of steps that your brain has used? Your brain is super fast. Your brain is super fast. Computer is slow. Therefore, the programmers are needed. Right? So you translate your brain thinking to be your friend so that you write a better program. So what is that I'm doing? So I take one variable, 1000, 1001. That is next number, sum them, add the next number, sum them, add the next number, right? You got a logic now. Translate that into algorithm. First, let's not even get into the code. Translate that into algorithm. Yes, Balaji, what is your question? Did you have a question? So I saw you raised a hand, so I wanted to attend you first. If it is
No, sir, no. Was by chance. No
okay,
questions.
and no problem. Now, Balaji, because you raised by mistake, I won't tolerate. You must ask a question there related to programming. Okay, I'll make sure your name is in the chat. Think of any question, ask it now. Okay, thanks. So I'm expecting your question there. So now this is the logic. Now, so what is the logic? So you take, okay, initialize. So what is initializing? The first numbers, right? Initialize the first entry number to a variable. Variable, now we have understood, we need a storage in the computer. So variable. So let's say var1 is equals to 1000. That is a step, right? So this is one step. And next what I have to do? Okay. So first, every time I'm adding 1. So you would say sum it to take the next second number also, because we needed 2 for the first time. There is a small logic here, but I'll come to that later. So 1001. Now, so take first and second entry, right? First and second entry. This is the initialization part. Step 1. You have done that. Then next, take another variable, that is sum. Okay, sum the first two variables. First two variables. This is your second step. This is your second step. So another variable called sum is equals to variable 1 plus variable 2. This is the next step. Now what is logic we have used? Where do we go next? Where is this adding 1? We didn't consider that yet, right? This we have only done initialization. So adding 1, which one do you add to this variable? You should add, right? The second one, not the first one. First one, we don't need it anymore because we have these two. So variable 2. So now what you should do is variable 2 is, okay, I'll use the red color coding. So variable 2 is equals to variable 2 plus 1, right? So this becomes 1001 became 1002 here. Now what should I do? I should repeat this step, but not with variable 1 and variable 2. But if you see this here, right? Sum has become 2001. So this sum I have to add the increased number. 1002 should be added to the sum. So now my step becomes, sum becomes previous sum plus variable 2. You agree with me? See, such a simple step. You added 1 and then you sum plus the new number. This one, variable 2. So variable 2 and your sum. These two are added. Is the problem solved? Not yet. We are only done with first three numbers. 1000, 1001, 1002. The question is 10,000 up to 10,000. How do you do? So here comes your programming, understanding of your programming language. So you need to repeat something. If I have to write it on a paper, this board probably I have to wipe it off for 100 times to solve this. On a paper, you need at least 10 papers to sum them all. That's why we have computers. So now you need to repeat these these two steps, right? You need to repeat these two steps again and again. Until when? That is where your loops, right? There is a language construct called loops will come. So while this variable 2 is less than or equals to 10,000. That's all. So this does the job of repeating. This while does the job of repeating again and again. So first time variable 2 is 10,001. Okay, 1001 is less than 10,000. Good. Enter inside 1001 plus 1, 1002. So now variable 2 became 1002. Okay, sum. What was the earlier sum? Sum was like 2001. So 2001 plus 1002 became 3003. Okay, repeat. Variable 2 is what? 1002. 1002 is less than? Yes. So now it became 1003. So now here 3003 plus 1003. 4006. Now variable 2, 1003. 1003. So it goes on. What is the upper limit? 10,000. Now what comes out after this is exited, your sum, if you print it, this will be your solution. Are you able to follow me? Are you able to follow me? Because this is the key point. Such a simple problem. Adding numbers. How do you translate that? First, how do you solve it on the paper? What is your logic? Oh, adding 1 is my logic. And then that number to previous number. Sum is the logic. Then sum. Okay, sum plus the next number. Sum plus the next number. Sum plus the next number. That is your logic. That part you have to nail it down. That is the key for anybody to be good at programming. Problem solving skill comes first, programming knowledge comes second. Your programming knowledge, you can learn programming, C programming syntax, okay, C syntax, Java syntax, Python syntax, Go syntax, Rust syntax, right, HTML syntax, many things you can learn maybe in 21 days. Syntax of any language can be learned in 21 days, not more than that. Problem solving skill is same across. There are new concepts. Yeah, how do you write it? How do you present it? That comes later. But for you as an undergraduate, problem solving is the key. Solve one problem a week. You will solve 52 problems in 1 year, 156 problems in your 3 years. If you solve problems and code them, 156 problems, my company, vsdevelopers.io, I will offer you a job. Because people lack consistency. People don't solve problems. They get irritated. They get frustrated. Simple problems, difficult problems. Yes. Problem solving skill. Then programming. We talk again as our ma'am's already talked, right? So I would love to visit all of you in person. We would continue to talk on this topic again and again and practice. So this 90 minutes is very small to discuss many things, right? 90 minutes is small. Yes, I like your participation, taking it on Friday evening. So we continue to learn this. So this is problem solving step. Then what happens? So you solved the problem on paper. Then what happens? You programmed it, you wrote an algorithm, then you coded it in C, C++ language, C language. Okay. Then what happens? Is that done? You're done. Can you go back home? No, not yet. There's some more things to be done. Good question. So somebody, should sum have a value? That is what I'm coming to next. Okay, your problem solved and you're happy? No, not yet. Who verifies that solves the problem? I can tell, like, you can write some lines and say, yeah, ma'am, I've solved it, sir, I've solved it. Who verifies it? Who validates it? We come that. Okay, good question, Pavan Tej.
Thank you, sir.
Maybe this second part of the questionnaire is very little internal, like of what kind of knowledge do you have about the programming. And it also has one important question, guys. What is your career objective after completing your graduation? That determines. If you don't have one, it's okay. You can form now. Okay. So you can ask your lecturers, your professors, okay, what is that I can do after graduation? Right? Not about how much money. Money will come. Money will come on its own. What is that you want to do? You want to solve problems? You want to, join big companies, or you want to start your own company, or you want to just be a freelancer? There are so many opportunities in the software industry. Or you want to teach? You want to be a researcher? So many things. So think of it. If you don't know the answer, it's okay, but you must think of it. That's the intent of my question.
Excuse me, sir.
Yes.
Sir, while we assign variable 2 and sum as the variables, right, sir?
Mm-hmm.
So if sum is variable 2 is lesser than or equal to 10,000,
Mm-hmm.
we should print the sum from 1,000 to 10,000.
So variable 2 is less than 10,000. Yes. Now variable 2 becomes 1,002.
Variable, yes, sir. So sum and variable should have a value, no, sir. Like,
So variable 2 has 1,000, but sum, it didn't have any value. No, it in the
yes,
beginning it has, right? Some value plus value 1. But value plus value 1 is sum. So 1,000 plus 1,001, 2,001 is sum now. So 2001 plus 1,002. 2001 plus 1,002. 3,003. That is a new sum.
yes, sir.
Right?
Yes, sir.
Then it keeps on going.
Yes, sir. Got it.
Yep, good. Ma'ams, if you have any questions, probably we can take this time and we can talk while the students are answering the questionnaire. The second question is a little elaborative, like they have to type the answers instead of multiple choice. So I want them to think a little bit. So I know you have indicated me earlier that they start with the C programming, right? C, C++, if you master, you can master any language. From my experience, it's not from theory, not from books. From my experience, you master C first, then move to C++. Every bit of it you must understand. While loop, what is that while language construct? Okay, so I haven't talked about integer, float, right? What is each data type? What is language construct? What is function? What is header file? What is hash include stdio.h? What is main method? Why should I write a main method? What is compilation? Why should I do GCC and filename.c? Entire process you must understand. Then even tomorrow a new language gets released, you know what to do. So in order to become a master at a programming language, you understand the entire ecosystem of the language, not just, okay, I know how to solve it. Yes, that is important. The most important is problem solving. Then comes the entire ecosystem of around the problem solving, around the programming. We'll talk more as we continue to do these kind of sessions. You know how much of software is inside a car? You might have heard of autonomous cars, right? The self-driving cars.
Yes, sir.
If you write your program, if you don't do proper testing and launch it into the market, just imagine what kind of chaos can happen for a self-driving car. It's the machine that is driving, and that machine is given a program, right? It's a code. So certainly you can write one, and the value of it is life. Value of it is life. So our programs, your programming skill, your coding skill can save lives, can give comfort to lives. Okay, so getting back onto the topic. Now you have solved the problem. Okay, you have solved the problem. Now what next? Right? So what next? How do you know that your program is working fine? What do you need to do? You need to test it. Right? You need to test it. So what is testing all about? Tell me. What is testing all about? So here one fundamental thing, again, I told you, while problem solving, you must understand the problem first. What is the problem? sum of integers from 1000 to 10,000. So you have a lower limit, right? You have a lower limit and you have a upper limit, right? This is important for such kind of programs. You must ask it. And in this problem, it is also very clear that he said only integers. So the data type is given to you, lower bound is given to you, upper bound is given to you. Operation, what is the operation to do? Sum is given to you. And even if you want to say, okay, print integers from 1000 to 10,000, print is the operation there, right? So these are the things you must understand from the given problem. Sum is an operation, integer is the data type, 1000 is lower bound, 10,000 is upper bound. First, you should decipher the problem, then solve it manually on paper, then derive a logic from it, write an algorithm, then write the code. This series of 4 steps. Decipher the problem, right? Solve it on the paper, write an algorithm, then code it. It's not over yet. Okay. Now you are done till 4th step. What is the 5th step? Is the validating your program, that your program works perfectly fine. Okay. So how do we validate the program, right? How do you validate the program? A programmer should also validate his code, right? He has to do unit testing. He has to do unit testing. Now, in this problem, there are very fixed size. There is no user input we are taking, right? We are not taking any user input. Fixed numbers, fixed values, everything is fixed. So there is not much to validate. But what happens if you say the problem is like this? Sum of integers from A to N. A and N are given by user. Now you like it, right? So now the challenge comes in. A value is variable 1 given by user. And the end value, this one, while loop, okay, I have erased it. So the condition, right? Less than or equal to 10,000. This one is N given by user. Now the magic starts. How do you validate it? How do you validate it? You say, okay, I asked him to enter 1 and 10. Okay, the output is coming. Yes, it might be coming. According to this solution, what you have written, yes, it is coming. No doubt about it. Right? 1 to 10, it sums up and gives. I'll say, okay, I'll give 10,000 to 1 lakh. Sure, give it. What happens if you give more than 65,000, I think 536, more than the capacity of an integer? You know, integer can hold only 16 bytes, right? Integer can hold only 16 bytes. The 2 power 16 minus 1 is the maximum value it can hold. Now, if I give you enter user input, which is more than the capacity of that, then what happens? Somebody will enter 3.5 to 10.5, where you have declared it as an integer. What happens? Even maybe Rakshit, right, will enter a character. He doesn't enter a number. He says, okay, well, enter the value of starting point. He will enter R. Enter this ending point, the maximum value. He will enter H. What happens? You're getting where I'm going? Validating your program. Validating your program. Who validates it? Right? With different types of data. And what happens if you run your program on your mobile? What happens if you run your program on a high-end configuration laptop? What happens if you run your program on a distributed computing system? Getting it? This is all the responsibility of a programmer. Don't just think that, okay, I coded, it's over. No. You solve the problem, you write an algorithm, write the code, validate it, then document it, how your program works, then your job is over. If you master these 6 steps, you have lots of opportunities for you. Lots of opportunities. Now, if you're good in all these, right, as I said, by the time you complete, I'm ready to take you. So you see, I do these programs in a couple of colleges, right? Many, in fact, in Hyderabad, also many engineering colleges I go. NIT Varangal, KITS is an autonomous engineering college. So I keep doing that. Now, what happens when they do? Some of the students are, very sharp, and others are very sincere, and few others are very consistent. At the end, I have seen people who are winning are the consistent people. Consistency. So far, I think around 10 people 10 students are like they say, okay, sir, I want to work for, support you, this knowledge sharing activity. I said, if you go to my website, right, I'll have thousands of, I think more than 100 programs in different 2 languages, right? So you see this, right? So it's in the editor mode. If you see this is WordPress website, and so I edit on my own if I want to make some changes. See, you see this. All these programs on the left hand side, there are many more which I haven't uploaded yet, which are on the GitHub. Okay, so there are many more codes that we have. So there are people who continue to support in this. I think this is not the. Yeah, let me just go back to the site. Yeah. So these are the programs, and along with that, there are around more than 30-40 programs still to be uploaded. If you see, there are programs for Java here, right? And there are, if you see binary search, I have for Java and Python. Java and Python. So students approach me that I want to contribute. Oh yeah, feel free to contribute. I'm okay. So you write you solve the problem, you write the code. I give you the problem. There is a big list of problems I have. So I want to solve it here, and write your email ID, contributed by so and so. Right. So and you claim it. Go in your resume later on. You can say, okay, my program is on the vsdevelopers.io site. You have your credentials here, your email ID, your description. It comes here. Very few people are consistent. People are excited, and then when they solve 1 or 2 problems, they are tired. It's just a brain activity, right? You need to put your brain, and then you need to keep it consistent. Every week you got to take a problem, or every 2 weeks you want to solve one problem, take it and solve it. Consistency. So that is the key to master your program. And as someone said, oh, I want to learn swimming, so I got 10 books. Let me read it. Oh, I want to learn swimming. I bought online books. Let me read it. I want to learn swimming. I listen to masters who has already swam for hundreds of kilometers. Oh, I want to swim. I want to watch YouTube videos. Oh, I want to learn swimming. I want to watch other experts talks. After doing all this, can you swim? No, you can't. In order to swim, what is that you should do?
Practical experience.
Yes.
Jump into water, sir.
Yes, sir, absolutely. You're right, Ritvik. So, and Ravindran, sir, yes, just jump into water. That's the right thing to do. You listen to my kind of talks 100. You listen to all my YouTube videos 1,000. You buy costly courses on Udemy, Coursera. You listen to paid fees. Listen to your expert professors. Nobody can help you to swim. Jump into the water. Start learning. Start swimming. So we all are here to tell you, okay, first wave your left hand, then right hand, keep your legs up, and then keep your core part, strong. These are all we can give you. You guys take pen and paper, take the problems, solve every day. Right? Simple problem, solve at least weekly 1 problem you solve. Weekly 1 problem, you would be a master in programming. You would be a master in programming. C, amazing language. Start with that. Okay, so here I stop the topic, how to master a programming language, and then we take it up questions. Because of the time, I have condensed it too many things into very short program. So we have discussed too many things into one quick 70 minutes kind of talk. Nevertheless, I think you caught up with me very well. Good. Okay, so we are on. Now I'll take up the question. So I'll go from the top to bottom. What is a DevOps engineer? Right? So good. So DevOps engineer, as name suggests, a developer and operations. Right? Developer and operations. What does a DevOps engineer do? What are the, who is a developer? Right? He solves the problems. He takes the problems, he solves it on paper, and then he writes an algorithm. He codes it, he validates it, he writes a documentation for it. You get it? That's the cycle of a developer. Now, where does he do all those things? What does he need? He needs a machine where he needs a compiler, right? Where he needs a Git. So Git is this source controlling, where you can submit your code. You get it? Right? So you can keep you will understand it better as you practice more and more. So if I go here, algorithms. So here is my team and myself have submitted codes. So this is knapsack problem. It's a Python code. So now you can access it. So I need as a developer, or you need as a developer, such coding environment, right? It's only for code upload. And somebody says, hey, this code has a bug. So somebody has to raise a bug, right? So what is a bug raising system? You should have a defect tracking system. What is a defect tracking system? You have Bugzilla, you have Jenkins. So there are open source and there are paid bug tracking systems. Okay, so you wrote your source code in an editor, right? And then you submit it to GitHub. Then you compile it. Right? For compiling, you can't do it on your machine, right? Because some of the projects will take hours and hours. If power cut is gone, or if power cut is there, or if you have battery, if your laptop crashed, then the entire build stops, the compilation stops. So therefore, we take machines from some other platform, we use them as build machines, compilation machines. Now you need a compiler machine, right? You need a building machine. That's called build machine. So you need a build machine. Then you compile your code. You need to run your test cases, right? What we have done is validation, test cases. Where are the test cases? So there should be a system to track test cases. You're getting all this? You need a test cases system. So QA engineer will log those test cases. So as a developer, okay, these are the unit test cases. I will write myself and I'll test it. Okay, you have tested. Then it goes to customer. How does it go to customer? There is a process, right? You have to upload it into one system. And then from there, customer takes it. Customer opens a defect. Then that comes to your defect tracking system. Then that goes to your code, right? So to fix a defect, it goes into your code. You have to fix something. Then again, you have to build it. Then again, you have to test it. Add a new test case. Because earlier, if the test case had been there, this bug wouldn't have come. So add a new test case. Add a new test case. Then publish it. Then customer takes it. You get this cycle. Besides you solving a problem, there is so much of ecosystem around you. That is called DevOps. That is called DevOps. Who does all this is called DevOps engineer. And in order to do this, you need to write a lot of code also. DevOps engineer does coding too. He writes good scripting, he writes frameworks. Okay, so that is DevOps engineer. I think you got a longer answer than you expected. So developer, QA engineer, DevOps engineer, network administrator, and release test engineer. There are many roles in the software, and so I would recommend you be aware of everything. As I think your BSc syllabus supports that, you can be aware of everything. Take problem solving as your main area. Problem solving, as your main area, programming as your main area. Later you want to become anything, you can become. No problem. Okay. So next question, sir, does mastering one language help in learning others? Absolutely. Absolutely. Master problem solving, then master one language. Really, C is my foundation. C is my foundation. So from there, it helps as you learned the art of master problem solving and the language syntax. We call them syntax and semantics of a language, right? So those syntax and semantics of a language will help you to understand any other language. Of course, there is a difference. Like C is a structured programming language. C++ is object-oriented programming. Go is a functional programming language, right? Python is a scripting language, which based on object-oriented. So there is a paradigm change inside how you write, but that's later, not now. Not now. It certainly helps mastering problem solving, mastering one programming language does help all other learning new languages. What are the different jobs we could pursue with computer science? I think we just talked about it, right? So you can be a developer, you can be a QA specialist, you can be a DevOps engineer, you can be an administrator, you can be database specialist, you can be a machine learning specialist, right? You can be a what do you call a programming analyst. Right? You can be data analyst. There's so many things that you can do with computer science. So many things. But for all this, I'm telling you, learn problem solving, learn programming. Then at final year, post final year, you can worry about what do you want to become. You don't worry about that. People will observe what you're good at and take you. You don't need to worry about it. So until then, problem solving, programming, problem solving, programming. That should be your bread and butter every day. What is the difference between C language and other programming languages? Yes, C, C is, I would compare it this way. C programming language is like your, parents, like my parents. When you get hurt, what do you say? Ah, Amma, right? So it's like mother. So you learn the C programming language, you can learn any other language. I don't say that C is a superset of all the languages. No, I'm not saying that. C is the foundation. Right? A building with a good foundation can go up to, right, number of floors can be increased. So if your foundation is strong, because C teaches you not just programming constructs, C teaches you operating system. Without understanding operating system, you cannot master C programming. And if this is operating system, right, here is hardware, this is operating system, this is your programming language, C directly talks to operating system. Java, there is something else in the middle, right? So this is your, behind is hardware, this is your operating system, this is your JVM, Java Virtual Machine, and this is your Java program. It goes to this and then to operating system, then to hardware. And then you come to JavaScript. Okay. Your operating system is here, hardware is here. And then your application interface, your above it is your browser, right? So your browser or the JavaScript platform is here. Then your JavaScript. So JavaScript first talks to your application. Your application then talks to your underlying environment. That talks to your operating system. There are so many layers to reach to operating system because of ease of using. Therefore, they are very easy. They are very quick, and also they're easy to learn also. C, I like it. You directly code into operating system. So therefore, your program that you write, C, can be used in embedded systems, can be used in your mobile phones, right? Can be used because it's very memory efficient if you are a good programmer, and it's very badly efficient if you're a bad programmer. C is like, however you treat it, it will behave that way. The different languages used in artificial intelligence programming. Okay, so artificial intelligence programming, wherever the libraries are available, you can use it. You can use R, is a programming language R. You can also use Python. You can also use Java, the TensorFlow projects. You can also use, there are machine learning libraries in C++ also. So the libraries that today they support are R, Python, Java, C++, and there are a few more specific to machine learning also coming up. Okay, share what you experienced when you started learning programming. Yeah. So one thing I can tell you, so learning programming is I banged my head many times. I get stuck. I can't move forward. Some of the problems I take, I can't move forward. Even including today. Some of the problems, algorithms that I want to solve, it takes me days. I get stuck. I get headache. I get irritated. This is all common when you're coding, when you're programming. So the same thing I experienced to when I was learning my C programming. Then there was help, like your professors. Like I have good professors. So I reached out to them, sit with them. And then the lab. Okay. Lab was like I was a bachelor and I was living in a room, a shared room with my friends. So I was less in my room, more in lab. And so my lab administrator gave me the keys. I can't stay as long as you want to stay. Keep the keys with you, and then go. And get I can come. I should come because I have the keys. I should come early in the morning to open the lab as well. So that was my experience. Yeah, you need good books. You need which is now the amount of information available is huge on internet, and your college reference books, professors, right? And they are organizing ecosystem like vsdevelopers.io, and you might be talking to many other good webinar presentation people as well, right? So all these, you have an ecosystem. Now what is needed? Sit and swim. Sit and swim. That is practice. That was my experience. Yeah, all these things were there. Programming language, C programming language by Dennis Ritchie is the ultimate book, which is very difficult to understand in the beginning, but you can follow it later. But you can start from there. If you have understood that, you need understanding of programming language and as well as operating systems. Very good book. Biology student in PUC, but now I have taken computer. Could suggest me to come up with C program. Sure, Ashwini. Doesn't matter. You solved problems in biology also. Remember. And in fact, the example I was sharing, my sister, I said, right, she was a biology student. So she's now getting good knowledge of Python. And you are much young. I think my sister is now, could be 32 years. Okay. You might be less than 23, the reverse of that number. So when she could learn with 2 kids, you can learn. Don't you? Right? You get it, Ashwini? So
Yes, sir.
what you have learned, what your background is secondary. Make your efforts now. If you have any questions, I share this presentation like at the end. I have added these details. You can contact me here. And yes, as Sudhasai ma'am sent a feedback form, do send your feedback about this session, about organizing this, about the content inside it, about the questionnaire. You'd like it, you don't like it, be honest, share it so that it helps ma'am and the all the professors in the computer science to organize things better. Okay, so I think many of you have joined Telegram group. Continue. I'll share my videos, new videos, problems there, and sometimes I announce my programs, workshops. So when you are my Telegram group, you would actually get it mostly for free because you are in my native community. So on the website, here is the email. If you want to know more, if you want to WhatsApp me, this is the number. So feel free. You can ask me questions. I'll ask you questions. Practice. If you want to join the community, contact me later. I'll keep sending you some programs to practice and solve it. And your contribution will go onto the website directly. You can have your email and your details as well. And I'll talk to ma'ams later on when I visit in person about the internship opportunities that would come up later. Ma'am, I think I've taken 5 minutes extra.
Thank you very much, sir.
It was very well taught. All the tips for memorizing of programming language, everything has been given. I'm sure the students are benefited very much by this talk, and we would like to organize few more in future. We will be in contact with you. Sir has already shared the YouTube video, and even sir has some videos which are already posted in his YouTube. You can just go through, and you can even be benefited with the Telegram group which sir has already made you join. I'm sure you all will be given few more programming tips, and even sir is master in algorithms as well. We can conduct some more sessions in future. Okay, thank you very much, sir, for a well-organized session, very well taught. I would like to thank even our management, our CE, sir, whose presence made our day. Then our principal, Usharani madam, and our vice principal, Ramanjanaya sir. Then the IQAC coordinator, Shilpi Dham, and our HOD, Durga Kalla madam. Then all our colleagues, then the students, dear students, without whose participation this event would not have been successful. We
Yeah,
will look for
thank you, everybody. It
many
is,
more
very pleasure.
webinars in future.
Thank you,
Okay.
Venkys sir.
Yeah.
We look forward to more beneficial sessions from you. And this is this concept of questionnaire is very a different concept, and we welcome that this one. And students, I hope students have responded in good number. And
It is like interactive, that made
Yes,
it interesting actually.
yes, yes.
So that was a good approach towards the students.
Thank you,
Thank
ma'am.
you very
So I
much, sir.
usually define my
very
own
much.
Good night,
program
all.
in the way.
Thank you,
So
Sudha,
thank
for
you, everybody, and thank you all the students for taking out time, and all the college staff. I'm very glad you invited me, and I'm able to talk to you like this with the young generation of students. See you all. Thank you.
Thank you, thank you.
Thank you, sir.